Industrialized Building System, IBS, is the term used by the industry and government in Malaysia to represent the adoption of construction industrialization and the use of prefabricated components in building construction. It is also widely known as prefabricated construction or off-site construction. This project relates to the application of IBS systems in building design. The IBS system implemented in our 3-story apartment building is known as the Iris Koto IBS system. It consists of prefabricated, lightweight modules for all parts of the building, including the foundation, walls, ceiling, roofing, columns, and beams. Yet, the system is fully flexible to accommodate third-party components. Made from fire-retardant, rigid cellular insulation and fiber-reinforced mineral composite, Iris Koto modules provide great insulation for maintaining indoor temperatures. It's environmentally friendly and affordable. Our 3-story apartment consists of 6 units in total, each unit having a floor area of 79.04 meters square, and is connected by a fire escape staircase. Within each unit, there are a total of 3 bedrooms, 2 bathrooms, a living room, a dining room, a laundry yard, and 2 balconies, all designed within 3-meter grid lines, reinforcing its modularity. With the assumption that the site of our apartment building is relatively flat with a compact soil composition, raft foundation is used due to it being a much faster alternative compared to other forms of foundation and its ease to cast the exact footprint of the floor plan. Its ability to act as both a starting floor slab and a foundation makes it the ideal choice for a design such as this. The soil is excavated to reach the required depth. Next, the flat foundation bed is compacted even further by ramming. Strips of damp-proof membranes, DPM, are then laid onto the flat foundation bed, overlapping one another pre-manufacturer's requirements to prevent moisture from seeping through. Next, strips of rebar and BRC reinforcements are laid over spacers on the foundation bed. Concrete is then poured over the reinforcements, thus forming the raft foundation, casted as a single piece. Iris Koto wall modules consist of a layer of hollow core insulated foam, EPS, as the primary layer, sandwiched between fiberglass mesh reinforcement, then coated with a mineral composite compound. The wall modules come in 2 standard heights, one being 900 mm in height and the other 1200 mm. The walling for a single level consists of 900 mm, 1200 mm, and 900 mm modules stacked consecutively to achieve a 3-meter floor height. Iris Koto bonding paste is used to strengthen the joining of the modules. Prior to fixing the Iris Koto wall modules, holes are drilled into the raft foundation and starter bars are added, reinforced by concrete. Rebars with required lengths are then tied to the starter bars securely. Next, the wall modules are inserted from the top of the rebars, aligned accordingly to allow the rebars to pass through the pre-molded core holes. Concrete is then poured into the core holes and set to form a sturdy, load-bearing wall. To strengthen certain parts of the walls, more than one rebar is added within a single core hole, imitating the structural strength of a column. When wall modules meet at the corners of a floor, part of the mineral composite compound and insulated foam layer is removed so that the modules join seamlessly, allowing the square-shaped core holes to merge and form an L-shaped core hole. More rebars are then added into the L-shaped core holes before concrete is poured. The modules are installed easily and quickly without requiring any high-skilled labor, decreasing the amount of time and cost spent during the construction. Jam liners are fixed on the perimeter of the window frame on both sides, forming a perimeter groove. The grooves ensure a snug fit for the casement windows with its adjacent wall modules, leaving a straight, rigid architrave around all surfaces. Casement windows are installed within the level of 1200mm modules, constraining and standardizing the height of all our windows. The width of the windows also correspond to the width of the wall modules. However, the length of our windows are classified into two types, one having a length of 600mm and the other 1200mm, both complying to the IBS requirements of MS 1064. In relation to the wall modules, the height of the doors is constrained within 2100mm. The width of our doors are classified into three types, one having a width of 900mm, smaller bathroom doors of 800mm width, and the main entrance door of 1500mm double door, all door dimensions complying to the IPS requirements of MS 1064. The installation of the doors are similar to that of the window components. A groove is formed at the perimeter of the door frame, forming a perfect fit for the doors with its adjacent wall modules. Once all walls are in place, the construction of the first floor can proceed. Temporary timber shorings are placed above scaffoldings throughout the whole floor to provide support for all the layers above before they are permanently cast in concrete. The floor for the balconies are also cast within the same piece. However, the floor for the toilet area is screeded 500mm lower than normal floor height. A corrugated foam layer is added, and steel reinforcements are added in the throes of the corrugation. Then, rebars and BRC reinforcements are laid over spacers on top of the foam layer. Lastly, concrete is poured in and set to form the first floor, casted as a single piece. After the concrete is set, the temporary shorings are removed and construction proceeds to the walls on the first floor. The process of walling and flooring repeats itself on the second floor, with concrete as the main bonding component, forming rings of load-bearing walls enough to support all consecutive floors and the roof. Handrails are installed at the balcony areas according to the design. The fire escape staircase connecting the three floors are precast concrete staircase, and since all the components are prefabricated, the flights are extended to include the landings. The bottom of the staircase is cast into place along with the ground floor. The flights are separated from the walls by a joint. The second and third flight of stairs are cast into place via notch connections that are prefabricated into the components. Concrete serves as the main binding agent between all sets of stairs into one single unit. Iris Koto roof modules are made of the same material as its wall modules, with a standard width of 1 meter. The modules are laid strip by strip according to design, bonded with Iris Koto bonding paste. Due to the waterproof and highly resistant qualities of the roof modules, no additional waterproofing membranes are needed. Strips of zinc sheets are pinned onto the roof modules according to size, and a steel skirting is secured around the perimeter of the roof. Upon completion of the apartment construction, a membrane paint coating is applied on the exterior of the wall modules and finishings are installed to the liking of the designer. The estimated time to complete this apartment building is less than 4 weeks, strengthening the fact that IBS systems should be widely implemented to attain better construction quality and productivity with less cost.